Differentiate each of the following with respect to x, simplifying your answer wherever possible. Okay, so we'll deal with this one function at a time. First, we're going to look at the function a part I. So a part I have y is equal to. Now, maybe tempted to use the quotient rule here because I've got a fraction, but actually the top isn't a function of x. So what I'm going to do is I'm going to rewrite this as 9 minus 4x to the power of 5. This is a negative index because it's a reciprocal, and we're talking about the fourth root, so this is a negative index of minus a quarter. So differentiating, this is a chain rule because I've got an inside function 9 minus 4x to the power of 5 to the power of minus a quarter. So dy by dx, chain rule, differentiate the outside first, so I get minus 1 quarter, multiplied by, well, the bracket, leaving the inside function untouched, decrease the power by 1. So subtracting 4 from the numerator, I get minus 5 over 4. Then I want to multiply by the derivative of the inside function. So the derivative of the inside function, 9 is a constant, so it just differentiates to 0. But then minus 4x to the power of 5 differentiates to minus 20x to the power of 4. Simplifying this expression, dy by dx, negative times a negative gives us a positive. 20 divided by 4 gives me 5. So I get 5x to the power of 4 multiplied by 9 minus 4x to the power of 5, all to the power of minus 5 over 4. Okay, part 2 wants us to differentiate this quotient. This time I have got a function of x top and bottom, so I'm going to start off part 2 by stating that u is the numerator, 3 plus 2x cubed. So du by dx will be 6x squared. Then state that v equals the denominator, so 7 minus x cubed. And differentiating v, I get dv by dx equals, constant disappears, I get minus 3x squared. Substituting this in the quotient rule, I'll just put up here, dy by dx is, it's important you get the order right on this, so v du dx minus u dv by dx all over v squared. So when I substitute this in, dy by dx, v du, I get 6x squared. Notice that I'm not going to expand the bracket here. 6x squared times 7 minus x cubed minus, I'm going to get minus 3x squared times this, so I'm going to put the minus 3x squared in a bracket for the time being. 3 plus 2x cubed. All over 7 minus x cubed all squared. So I can take 3x squared out as a common factor here. So simplifying, taking 3x squared out as a common factor, I get left for my first term 2 lots of 7 minus x cubed. The middle term was a double negative, so it's a positive. I've taken a 3x squared, so I get plus 3 plus 2x cubed. All over 7 minus x cubed squared. I can tidy this up just a little bit more. dy by dx equals 3x squared. 2 times 7. Well, the important bits here are going to be 2 times minus x cubed. It's going to give you minus 2x cubed, and it's going to cancel with a plus 2x cubed. So all that's going to be left is 2 times 7, which is 14, plus 3. So we're going to get left with 17 inside the bracket over 7 minus x cubed squared, and then I can just expand that out to give me dy by dx is equal to 51 x squared over 7 minus x cubed all squared. Let's have a look at how the marks are awarded for part A. So in part A, if you have got this first part of the differentiation correct, then you get a method mark, assuming that you have got some sort of function multiplied by some sort of function here. There must be some sort of function here. Next, you get an accuracy mark if you get to this full simplified version because you've got the correct function here. Next, if you have got 7 minus x cubed times by some function here, you can have, and you've got the 3 plus 2x cubed times some function here. For these bits here, having these bits here correct, you get a method mark. If you have got the correct functions in here, then you get an accuracy mark. And this all assumes this must include this denominator here as correct. Okay, so you must have the fraction with a denominator. Doesn't matter what you got for these two here for the results of differentiation. If you've got these three aspects, you get a method mark. If you've then also got these incorrectly, you get the accuracy mark. Finally, if you've worked all the way through and simplified, and then you get down to this simplified version, you get an accuracy or answer mark, but only if you have got exactly this correct answer only. Okay. Now, let's have a look at part B. Part B says to sketch the graph of y equals sine minus x for the values satisfying minus 1 less than x less than or equal to 1. To help me with this, actually, I would start off by sketching a sine graph between minus 1 and plus 1. And a sine graph between minus 1 and plus 1 looks like this. So at 90 it goes up to 1, at minus 90 it goes down to minus 1. I've chose this range here because it's the smallest range in which 1 to minus 1 is covered. It's what we call a principal solution range, and this is what your calculator will always give values no matter what value you put in. If you do sine to the minus 1 of it, it will always come between minus 1 and minus 1, but if you evaluate any angle, it will come out between there. Okay, so now to do the inverse function, what I'm going to do is reflect it in the line y equals x, and so what we get when we reflect this in the line 1 equals x, if this is y equals sine x, then when I reflect it in the line y equals x, the graph that I get, well, this flips round. Actually, I'll do it on here. If we had the line y equals 1 over x, it's like this. Okay, the graph would reflect round like that and reflect round like that. So the graph that I get for sine to the minus 1x looks a little bit like a cubic. It's not a cubic, it just kind of looks a little bit like a cubic. So this is minus 90, this is minus 1, this is 1, and this is 90. Okay, so part I, it says first by rewriting y equals sine to the minus 1 as x equals sine y, find an expression for dy by dx in terms of x. So I've got x equals sine y. If I differentiate each side with respect to x, I get 1 is equal to, differentiate sine y, I get cos y. Remember to multiply because this is now implicit differentiation, cos y dy by dx. I'm now going to divide both sides by cos y. So I end up with dy by dx equals 1 over cos y. Now it does say I want the expression in terms of x, so now I've got to look for expressions somehow in terms of x. So the first thing I'm going to do is I'm going to take sine squared y plus cos squared y equals 1. I'm going to rearrange it so that I get cos y equals 1 minus sine squared y. And I've taken a square root because I've not got cos squared y here, I've just got cos y. So now I can write dy by dx as 1 over the square root of 1 minus sine squared y. You might be wondering why I've done that. Well, at the beginning, I've got this expression x equals sine y. So this leads to x squared must be equal to sine squared y, which is exactly what I've got in my denominator. So I then write dy by dx is equal to 1 over the square root of 1 minus x squared. Okay, let's have a look at how the marks are awarded in this question. Well, if you manage to get a reasonable sketch, I know that's not the greatest sketch there, perhaps I should do something a little bit better. You know, it's a little bit hard sometimes working with a graphics tablet. Let's correct that there. So I should have something that's a little bit perhaps more like that. Still come out just as bad. If you've done that anyway, either way how you've done it, you can have a graph mark for that, and that's just 1 mark. Working through this solution, you get your first mark if you have got B1 here. You then get your second mark if you've got down to actually saying that we've got this reciprocal here. So dy by dx, we can come down to this part here, we can have a B1, and then finally we can have a B1 when we get to this final result here. There was an exclamation mark, sorry, apologies. Gradient of this is positive, so just had to justify. I've missed that bit out, so I apologise. Not perfect. Exclamation mark if you state that positive square root used, since gradient is negative. dy by dx equals positive. Okay. Well, I hope that all made sense and that you understood the explanations to that question. Actually, we might be missing a B1 mark here. Let's just make sure I get the B1. Okay, so B1 here is used for getting to this square here. So apologies, just misread the mark scheme there momentarily. Okay, I hope all my explanations made sense and you were able to understand that question.